Negative 3, 3, yeah. Sorry. Negative 3, 3. Okay. Negative 3, 3. And let's do another coordinate, another point. Over here, let's say negative 4 and this makes 6, yeah, okay. And how about over here? Negative 2. So this is negative, this is negative 4. How about this negative 6? Negative 2. Okay. Now I'm going to transform the function fx so that I have f prime of x, so that I have f of 2x. Okay. So how are we going to do that? I know that when a is greater than 1, I'm going to string horizontally by a factor of 1 over a. By a factor of 1 over a. And I want to string horizontally. When I say stringing horizontally, or stretching horizontally, okay, you're going to keep the y component of each point. Okay? So 6, 3, and negative 2 stay the same. You never change that. So you're going to change the x component of each point. But how much we change?
2 to 3.
We change it by the factor of 1 over a, and my a is 2. It means that my new point, instead of negative 4 and 6, my new point will be negative 4 over 2, because it's a factor of 1 over a. Okay? And you keep 6, because it's the y component, you don't change. Okay? The same thing for the other points. Instead of negative 3 and 3, we transform this to negative 3 over 2 and 3. And the same thing for negative 6 and 2. So I transform become negative 6 over 2 and negative 2. So all my 3 points here, I transform to new 3, these 3 new points. Okay, so my new point will be what? Negative 4 over 2 give you negative 2. Okay, so give you negative 2. Where's negative 2? Negative 2 and 6. So negative 2 and 6 right here, negative 3 here. Maybe negative 2 and 6 right here. Okay, that's my new point. Negative 3 over 2 and 3. So negative 2 here, negative 3 over 2 is kind of something over here. And 3, okay, because this is 3. So that's my new one. Right? And negative 6 over 2. Negative 6 over 2 gives you negative 3. Negative 3 is over here. Right? And negative 2. Negative 2 over here, so my new point will be over here. Okay, so my new graph, it's kind of thinner because we don't really scale it, but it should be thinner. Okay, it should be thinner. But this is the way and the method of transform to the new coordinate. Okay. So if a is between 0 and 1, for example, if a is 1 over 6, for example, then you divide the x component by 1 over 6. So if you divide the x component by 1 over 6, for example, negative 4 divided by 1 over 6, then which give you what? Negative 24. 24. Negative 24. Okay, so the new point will be negative 24, comma 6. Okay. Any question?
You said that for the horizontal?
That's for horizontal.
Okay.
Okay. So for horizontal, doesn't matter the factor shrinking or stretching. Okay. You always keep the y component. So I'm gonna just write. Always hit y coordinate. So the y coordinate component it never changed, okay? Okay, only the x. Any question? Yes.
Why did it shift to the right? In the example, it never shifted anywhere.
Let me see. It should be. It is.
The math works. So I think it's just because it doesn't.
In the example, it's not shifted because in this example over here, it's just like I don't give you the value. It's
Okay,
just
so
here.
it usually shifts.
It's I don't say that you. I can say well, it's not always shift, but because this is absolute function, it's not shift.
Okay.
You know, but it could be. It could be shift. Okay. Yes.
I think you how do I graph it?
Is it, you always keep the y value even when it's horizontal or vertical? Or only?
For vertical, no, for vertical it's
No, it's following the direction right here.
for horizontal, yes. For vertical, you keep the x, you change the y.
And go to the next step.
Okay.
And then
You actually change the y. Okay. Any other question?
because it wants me to do this.
Alright. Good. Everything's clear. Just remember that you always have to keep y and change the x. So you see the transformation. As I say, that transformation concept is the tool. It helps you to generate another function that's more complicated. You can derive another function that's more complicated because you can add to a number and you subtract by a number, you stretch or you string, and it gives you a function that's more complicated. Okay. There's another way you can get a more complicated function. We use the concept. Actually, it's not a concept. It's just a method. You can combine many functions together. When you combine a function together, it creates another new function, and that new function is more complicated than the parent function, more complicated than the basic function. That function we call the piecewise function. So today we're going to talk about piecewise. Piecewise. Let me give you a function that looks like this. I call this function f1 of x. Okay. And f1 of x is equal to negative x plus 2 squared. Anyone can tell me what kind of function it is?
It's gonna be
Square function?
What?
Square function?
A square function. It is. It is because it's considered as the parent function, even though this is transformed already. Because you see the second degree over here, every time you see the second degree and it's the highest degree in that expression, you know that's square function. Yes. Okay. But in this one, we have transformation. Anyone recognize any transformation here?
Shifted to the left.
It's shifted to the left. Why?
Because it's plus 2.
Because it's plus 2.
It's reflected across
Reflected over
the
X.
x-axis because
Negative.
because of the negative. Ah, very good. I mean that you learn my lecture during weekend. That's good. How about the domain? What is domain of this?
should be negative.
Negative
Positive
infinity.
infinity.
Negative infinity to positive infinity. Yes, it is. Because just visualize your parabola curve of the square function. The domain is from negative infinity to positive infinity, right? And even you shift it, you move it to the left 2 unit, and you flip it over the x-axis, the domain is still there, still the same. So the domain of this, okay, good, from negative infinity to positive infinity. Perfect. Alright. How But this is the absolute function here. Everybody know. Any transformation.
Then moves to the right too.
And move it to the right too because of?
Minus 2.
Because of minus. Because of the minus. There's like 6, 7 formula, general formula. I already gave you something like this. How about the domain? All real number. Also, all real number. Negative infinity to positive infinity. Or you can use R. I mean all real number. I believe in your system, when you do the connect math, I think they like this. They do this, right? Yes. Okay.
Yeah.
So all real number. Very good. Now I have two functions. And I want to create a piecewise function. Okay? So my piecewise function, I call it f of x. Okay? And I'm going to use the curly bracket, okay, to combine these two functions together. I combine the first function, okay, and I combine the second function. But the domain, how about the domain of this new function, f of x? Of course, it's not from negative infinity to positive infinity anymore. Okay? We're going to have a restriction. We're going to have a restriction, I mean, something we call that, there's another name for that, we call the subdomain. So instead of having negative infinity to positive infinity for the domain of the first function, we want to restrict it to all the value that less than, let's say, less than negative 3 only. Okay, so that is the domain of the first function. All the value that's less than negative 3. Okay. And for the second one function, I also have a restriction for all the value that's greater than equal to negative 3. Okay.
Greater than equal to?
Yes, greater than equal to, yes. Oh, greater than equal to 3 only. 3. So, it's restriction here, okay? It's restriction here applied to each function, and we call it, the restriction here, we call the subdomain. For the subdomain. So it's not domain anymore, we call it subdomain. Because piecewise function is defined on a different subdomain. Okay? So fx is the piecewise function. And each function in piecewise function, so we have two functions here. Each function we call it subfunction. Yes.
How did you get the subdomain?
What's that?
How did you get the subdomain?
Oh, this is just a part of, because I use this subdomain to create this,
Okay,
this
so
one.
they-
Yeah,
they come
they're
from-
going to give you, yeah. For the question, of course, they must give you the subdomain. Then it will be the piecewise. Otherwise, if I don't have that, it's not a piecewise function anymore. Okay, so. Alright, so on the first part of this, I want to talk about the definition of the piecewise function, and we want to go through its definition officially. Okay. So, piecewise function and of course, because it's called a function, so you know it must be a function, right? Piecewise function is a function, of course. And because it's a function, it must satisfy vertical line test. Anyone remember vertical line testing?
Draw that on the graph and just
Lines
see
on
if
the
it's.
x-axis and
Yeah.
touch that in one thing.
Touch at one point, right?
Yeah.
If it intersect the curve at one point, then it satisfies vertical line test. And we satisfy vertical line test, I know that that graph, that curve represents function. Okay? So piecewise function is a function. More than that, it's a combination. It's a combination of more than one function. More than one function called subfunction. We can combine more than two. We can combine 3 functions together. We can combine 4 functions together, as many as you want, to create the piecewise function. Okay? And each subfunction defined on its subdomain. Okay. Each subfunction must be defined on its subdomain. If it's not defined on its subdomain, then this does not create, then it's not a function anymore. Okay? Then we don't have piecewise function. Okay. Example. I can create another piecewise function as I want. Something like this. F of x equal to, let's see, my piecewise function here include 3 subfunctions, and the first subfunction is x squared. The second subfunction is 4. And the third subfunction is 4 over 3x. But I have not defined the subdomain. So if I write like this, it's not a piecewise function. So we have to define the subdomain. Okay? So my subdomain for the first subfunction will be if x less than negative, whatever I want to. Okay? But be careful, it must satisfy the vertical line test. Okay? And we're going to check if this piecewise function satisfies vertical line test or not. Okay? If it does not satisfy, then f(x) is not a piecewise function. It's not even a function, let alone be a piecewise function. Okay? For the second subfunction, my restriction will be between -2 and 3. And for the third one, it's greater than 3. Alright. How do I know that this is a function? Of course, we have to graph it. Because if we graph it, and we apply the vertical line test, and if it intersects that curve at one point, no matter what you go, where you go, you scan horizontally, yes, then I know that that curve represents a function. Then you know that it's a piecewise function. Okay? So how are we going to graph it? Let's see. So we have 3 subfunctions here, and we have 3 subdomains. Okay? The first subfunction everybody know already is the parabolic curve, right? Mm-hmm. It's a square function. The second one is just a number. So how the graph look like?
A straight line.
It's
A straight line, but how straight line?
Just on the floor.
Horizontal.
Yeah.
Horizontal.
Horizontal.
Yeah, it's horizontal line. Okay. Alright, what kind of function for the third one? What kind of function the third one?
A line going down for.
What's that?
Rational function?
It's a linear function.
It is linear, because if it's radical, it will be 1 over x. Yeah. 1 over x. And we have only 2 typical examples of rational function I already provided you last time. Okay? So all those basic functions, you have to memorize, guys. There's no other option, no. You have to memorize all of them. The graph, the domain, the range, everything you have to memorize. Okay. So this is linear. This is a horizontal line. This is a parabolic curve. Okay. Okay, let's graph. Okay, let's graph it. I'm going to graph one by one. Then after I grab it, I'm going to apply the restriction. I'm going to apply the subdomain onto that graph. Okay? And you will see that we're not going to take the whole part of the graph, but we just take a part of one or maybe 2 branches of the graph. That's y, x. All right. How we grab the first one?
A regular parabola.
A regular parabola. Okay. Regular parabola. So I just plug in a point. 0, 0, right?
Yeah.
1, 1. Negative 1 and 1. So let's grab this together.
Negative 2.
2 and 4.
Yeah.
2, 3, 4. Negative 2 also give you 4. Okay.
That's where it starts.
Let's see, maybe, oh yeah, I think that's good enough. Huh? I think it's good enough. So I'm going to have a parabola curve like this. There you go. Beautiful curve. Okay. Okay. And I have over here negative 2 and I have 2. So if I graph like this, the domain is the everything. The domain will be negative infinity to positive infinity.
Right.
But we have a restriction. We want only the value that's less than negative 2. So just imagine this. So after you graph it and you get a piece of paper, okay, and you start cover everything that's greater than negative 2. So this is negative 2 right here. And I cover everything. So my graph will be only this branch. Okay, so I'm gonna just delete this. We don't want this anymore. There you go. Everybody clear?
Open circle too.
We're gonna have open circle. Very good. Because right now we don't want to include negative 2. So we have open circle at negative 2. Okay. Any question on the first subfunction? Good, huh? It's not really that bad. Okay. For the second one, okay, I know it's a horizontal line, and it goes through 4. So it looks like it'll be something like this. It's 4 right here, so it'll go through 4, so it'll be something like that, right? Okay. But we don't want the whole thing. We want only between negative 2 and 3. So 3 right here. Okay, 3 right there. So we want only between negative 2 and 3. Okay. So if it is greater than 3, we delete it. We don't want this. Go. And this is a dot 1. Okay, because we include 3. And we also include negative 2. So my empty circle here, it becomes a full circle. So you see that the full circle, the solid circle, is always take over the empty one. Yes?
Wouldn't those be 2 different circles though?
What's that?
On the parabola, wouldn't 2 be,
It's always take over the empty one.
but wouldn't they be separate? Because on the parabola, negative 2 would be lined up with 2.
Negative 2 will be lined up with 2.
2 on the y-axis,
2 on the y-axis.
wouldn't it?
No, because we at negative 2, we always look at negative 2. Negative 2 is right here though. So if you say 2 on the y-axis, nothing to do with that because we consider the x, not the y. So if you cover,
But just drawing the parabola would go through.
yeah, my parabola like this, right? My parabola like that.
He's saying shouldn't it have its own individual circle?
Yeah.
No,
No?
no, it's take over. It take over. It take over the empty one. Okay?
Because it's included in the.
Because it's included here, even though it's not included here, but it's still, it's take over. All
I'm
right.
just confused on how the y-axis lines up for the parabola with the horizontal line.
We don't consider the y-axis. You know? Everything is x. Okay, look at that. My graph here is like this. Okay, my graph is like this. But you cover, you see that we want everything less than negative 2. So if greater than it's negative 2 right here. So I cover that. You see that? So we only have this break. So we're gonna erase everything. Because we don't want it. Okay? So you just take a piece of paper and you cover whatever you don't need it. And whatever left will be the graph. Okay? Any other question for the second function? All right. How about the next one? How are we going to graph the next one?
It's just a line.
It's a line, but how we graph that line?
It goes upwards. It's a positive slope.
It's positive slope.
But it's
You can't
everything
give
greater
it
than
3.
What's that?
It's gonna be.
Everything greater than 3, yes. But how are we going to graph that line? Let's graph the whole line first, then we apply the restriction.
The first
It goes
point is
through
4.
It goes through where?
The origin.
The origin. Good. Because the slope intercept, the y-intercept 0, right? We always start with y-intercept 0. In this case 0. So right here, we use apply rise over a method. 1, 2, 3, 4. 1, 2, 3. So we go over here, right? It look like it's kind of like this. Okay. However, because we want is greater than 3 only, so everything that over here, we throw it away. And my final answer is this. So this is open circle, but we already have the closed circle. Yes.
So is this just a Frankenstein of a bunch of functions?
Yes. I can say it. Yeah. Okay. So this is open circle. However, the dot, the closed circle is take over this open one, so we still have closed. We have it. Okay. So over here we're gonna have a curve, a parabolic curve. Over here we have a horizontal line and a slanted upward line. Now, by just look at this graph as a whole piece, do you think that it satisfies vertical line test?
Yes.
Yeah. Because look at that, you scan vertical line, you see that it's got 1 point, everywhere, right? Everywhere. So I know that my piecewise function is a function. Okay? Because it satisfies vertical line test.
And if someone were to ask you to like write the domain of this, how would you do that?
For the domain of this, you see that because this is keep extending to the left, right?
It's
This is extending to the right. So the domain in this case for the whole function is still from negative infinity to positive infinity.
Okay.
Yeah.
All real numbers.
All real numbers. Any other question? Okay, let's see if I can give you some example and you can practice. We have enough time. How about this one?
Why is this broken?
Hmm?
Why is the graphic on here broken?
No idea.
Okay, how about this?
It literally is not.
Let's get together, okay? Let's get in a group, okay, and try to do this problem. So I have the function like this y function. And my first subfunction is negative 3x plus 7 if x is less than negative 1. Okay. The second one is x squared plus 3. If x is between negative 1 and 4. Okay. And the third one is 5. If x greater than 4. Alright, so I want to get together in group. Okay, let's get together in group and try to discuss how to graph this piecewise function. Let's turn around. Let's turn around and talk to your classmate. Yes. Yep. Over here. Please turn around here. Okay.
This is absolutely not.
Your original function is going to be
Okay.
It was a literal problem, sorry.
positive one or negative
Yes, that's why.
What?
No,
Okay.
What's their deal?
because no, it's negative 2 and 4, yeah, because negative 2 is square. It's not negative 2 and 2, yeah. It's not negative 2, it's negative 2 as well.
Yeah.
Alright, go ahead, turn around, go ahead, talk to each other, over here, turn around. So the first one, what kind of function, the first subfunction?
Linear function.
Linear function, everybody know how to graph linear function? Okay.
With curves, right?
No, just a line.
Okay.
Turn around, talk to each other, guys.
Why is this broken?
It doesn't.
Hello? Are you sure that was possible? I'm sorry.
I was like, did I miss something else?
That's why you see it on a bunch of record all the time.
Alright, talk to each other, guys.
Y equals.
Yes.
Right?
Who are you?
Because we're gonna need all of this.
So loud.
Right?
So we're gonna have to erase all of this.
Yeah, first you would just graph it like a school, and then as soon as you get to -1, you would erase everything.
Erase everything else.
That's basically it.
Yeah.
And then read all the nice words.
Oh, I know. That's so stupid.
You said it.
Yeah.
Okay.
I wasn't asking you.
I never thought you were,
I don't think it matters.
You were.
I don't think it really matters.
Keep this in open circle, right?
I didn't say anything. I said what though? Is that a one? At the top.
That's it.
No.
What?
Okay.
Yeah.
So then
Yeah, that's a
the
negative.
other one.
I wasn't asking you.
You were
I was
asking.
asking you Esther.
That number?
Wait,
As
I'm
soon as
gonna
further
do
away
my
from you,
colors.
that's less than well.
Yeah, but the thing is, think about it,
Yeah.
when you do the
Okay,
restriction
so
in the -1, then it doesn't matter whatever this.
If I see
Yeah, but if you
zero,
wanna-
Oh, you want to start from all the way to
I
seven?
could live with
No, I
light
want to
gray.
start from
He still has a response, okay?
I mean, I can
What
still
if
do
you want,
that.
then you have to apply a
More
restriction.
Alright,
Six
like,
equals one.
Mine's like a
you
buzz.
can start between like
Kind of.
-1.5, but you know,
Or you can, you can, instead of using right over run method or graph it, you can use the x and y intercept. One of the methods you, in the test I asked you to do, on the test, I asked you to find x and y intercept, right? And you find x and y intercept and you just connect those two points.
yeah, but then we have to erase absolute size.
I started.
So we only include everything that's less than -1.
Yeah.
And if we want to use whole numbers, -2, -13.
Oh, I know what you mean. I know what you mean. Well, just try to figure it out.
I started.
13 or 14?
Is that too much?
For -2? Even that's
Yeah.
correct. That's +6 plus 7, that's 13.
Yeah, it's like 4 separate.
It's 7, but it won't anyway because it's less than that. So basically we're graphing 1 squared.
I just thought it was.
3.
He's like, he
It's up to
can't
you
even
guys,
think.
it's up to you.
I mean, I know.
I'm trying.
All the way down.
Alright, 3-4 more minutes, then I'm gonna correct the problem for you guys, okay?
And then
Before you, and the other one is after.
It's gonna be a lot.
Yeah, I'm trying to see where that stops. Which part is it?
Or
Oh, no.
That's the part I'm trying to figure out.
Okay, well, if you just draw the little drill and then erase, that's how you did it on that one.
Okay,
So
then
I
the
was
last
bad.
one.
It costs a lot of money. It did.
Here.
Because when you start saying, oh, this eliminates this one, this eliminates this one, that's when
Oh.
X is equal to 4.
right?
You
No,
plug
okay,
it.
let me,
So
okay.
if you do
So put it in.
negative
like,
1,
really simple terms.
negative 1 squared,
Yeah,
1
just
plus
draw the
1,
standard
that's 4.
So
So that gives you that. Or you can take the base of 4, which you know is
And
parabola.
then everything.
Go up to
Yeah.
the movement of it.
Negative 1.
But or you can go 0 squared. No, I'm just making the entire side. I'm basically, but these are your starting numbers and your ending numbers. This is your ending number for each one. This one is starting number.
Basically, the way that I learned.
That's how you kind of think of it. So you just plug in. But this one you go.
So it's you basically make 4 graphs. You graph
Negative 1. Plug in negative 1 here.
it all in one.
Negative X squared is 1 plus 3. That's your first thing. And you know, you go from 1 to 4, and that's how you get your graph in this part. And as soon as you hit 4, you're Okay, got any more questions?
Last one is that if you write like this, I'm mine. I'm mine
Okay,
because
so-
for this one,
That's what I'm kind of nervous about.
Like, if you take, you'll take this graph, right?
you have to write like this.
I'm
Start
bad at
from
art.
here.
Because if you write like this, that's not the point. If you write like this, it gives you the whole point. This is x, of course. This is the road. And you can tell you have x, y, and z.
You know when the road goes, I could do like 3-point perspective and all that stuff. Okay.
Everything else, I'm so bad at. It's miserable.
So you're.
I can't draw.
I
Yeah, no, 17, no, we are 16, 19, 16 plus 3.
So I
Why did you want to put on the graph?
I'm gonna have all of this that you put it as a text.
That's why I get confused.
You put it as a whole.
This is technically, you know,
You got it?
it's finally
Yeah.
Oh, it's going?
That's all I'm good at. I don't understand what else I
This is
can
not a correct number, but the way you write.
I took a
First of all,
class
the first one,
Yes.
the way you write.
I really
That's why
but then my sister's thinking is getting her master's.
So for this one, I just plug it in on negative 1 on X.
I'm not talking about.
Yeah, negative 1 is X. See what you get.
Jacob, I have a question.
No.
That goes to
4 plus 7. Look.
So means. Yeah, this is not that much wrong. The way you write must be like this.
I kind of like
Does this affect the transition?
That leaves up the graph stats.
Okay, and this is the left and right, right?
Yeah.
This is better, much better
No,
than
that
I care about
straight
this.
six.
It's wrong.
I don't
It's stupid.
No,
He right.
I don't
When you write it,
It's okay. Here's the
No.
thing. It's a linear function.
At least in
Just
physics, I'm trying to find
Just
something.
plug it in. That's all you have to do. It's a big graph. The biggest one you should probably have
you
is
even
20.
write like this.
Oh,
Two. Honestly, 0.
last time I checked, I hated it.
The top 20, the top white line is 20.
Long and I don't
0.
care.
Negatives.
If it's parentheses.
Positives.
It's jolly good fun.
like I was saying before.
The biggest point is
We're
19.
using cross on your y-axis. That's 7.
Yeah.
Okay.
That's 7. We're using cross on your y-axis.
But you're gonna be all
Kind of crazy.
Alright, let's go through this, guys. Let's
That's
go
why I was
through this.
trying to figure out exactly.
Alright.
I did something.
Alright. That's it. Let me.
I know which I just like when
You don't have to worry about the transition, just plug in the point of the graph.
Alright, everyone pay attention here. So I'm gonna grab the first
You
one.
don't have to think about the transitions, just
Okay.
the point.
I know that the first one is a linear function, right? And you start at you start at
You're
7.
thinking way too much.
Pretty big one.
Yeah,
So you start at 7.
So stop.
Excuse me again?
Sorry.
Yeah. So you start at 7. 1, 2, 3, 4, 5, 6, 7. Okay?
Oh, that's long.
And I know that it's going down 3 units and going to the left how many? 1. So going down 3, 1, 2, 3, going to the left 1. So my function will be something like this. There you go. But we just get a part that's less than -1. So -1 right here. Okay? -1, and you have to plug -1 into the function. If you plug -1 into here, what it give you?
Gives you
10. Is that
no 11. Could that be
10?
10.
10. So we 10. So -1 gives you. Let me see something. Less than -1, 6, 7, 8, 9, 10. Okay. So 10 right here. 7, 8, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So right here. There you go. So we're gonna erase this part. Alright. And we're gonna have an open circle right here. So that's this will be the first branch. Okay? The second one, it is what? It's a quadratic. It's a square function. And what is the transformation here?
Up 3.
Up 3. So up 3, 1, 2, 3 right here. So we're gonna have something like that, right? 1, 2, 3, 4. So we have something like this. Here you go. But we want only between -1 and 4. So -1 right here. -1 right here. So we're gonna erase this part. Okay, and we have to include -1. So over here will be the dot one. Okay. And at 4, if x equal to 4, you plug it in. 4 squared give you plus 3, 19. So that's a pretty big one. So 1, 2, 3, 4. So this all the way, I don't know, maybe somewhere over here. It's open circle. Okay. It's all the way up there. So it's 19 over there. Okay. So it's 19 over here. So on the test, you just need to mark this 19.
Oh, you don't need to like.
Then I know.
Okay.
Alright, then I know. Alright. How about this one? Fx equal to 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 right here, right? And usually it will be the horizontal line, but we want is everything's greater than 4. So 4 right here. So, and we want to include 4. So this will be something like this.
Close circle.
That's it. All right. Any question?
I just use big numbers.
Any questions? So you have to, if you apply the vertical line test here, it still works. It still works. And you see that because at 4, you know, my graph is not really that good. So at 4 is here. There you go. Okay. It's still okay.
Even though technically those are.
It's not overlapping, so it's still.
Because it's an open circle.
Yeah, because it's open circle.
So if there was 2 closed circles, then the vertical line.
Yes. If it's 2 closed circle, yes. This does not satisfy vertical line test in that case anymore. Okay. Okay. Any other question? Alright. So you see the transformation is one of the property of the function. We know the domain range is also another property of the function. We also have a few more property, and one of the property that is very important, it is even and odd. So on the second part, I want to talk about even and odd function. We want to know when it's even function, and we want to know when it's odd function. Let's go through this really quick, and that's it for today. Okay? An even function is a function when it satisfies f of negative x equal to fx. Okay. So in this case, the graph of the even function will be symmetric about the y-axis. So I said its graph is symmetric about y-axis. So I can say, oh yes.
Is there a problem with figuring this out just by looking at the degree of the function?
Yes, but I mean, I don't think that's a good idea to do that. So I always apply this this property f of negative equal to fx, because when you use that, it shows me that you really understand. You show me that you really do the work and you understand the concept instead of just look at the degree. Okay, because the degree it just work for some function. It does not work for everything. Okay, so we're gonna go through the example later. Okay, that's this even function. And if it is an odd function, if f of negative x equal to negative fx, okay, and the graph will be symmetric about origin. I'm sorry. So an example of odd function is x to the third power. The cubic function is the odd function. Okay. So next time I'm going to give you a couple more examples, and we're gonna learn how to check if the function is even or odd. Okay. I think that's all for today, guys. Do you have any questions? Let me know. Okay.
Does anybody know how to stretch
If there's
the
any concern on the test, let me know also.
graph on here in the connect math? Because I don't think I'm stretching it right.
I won't try on the phone.
Everybody got assignment number 4 ready, huh?
Like it says vertical stretch it by 4. I don't understand what's going on here. I thought it was just going up.
Yes, thank you.
4, but it's not. Any way I count it. So I don't really know what to
You
do.
have not received. So you should be able to do number 1 because last time we did number 1. Number 2, because we can do it now. It's today. By next week. Oh, by next week. It's due on.
So that's the original one, right? Did you do it by order though?
What is this? What's over here? What was that?
I think that was from the last class.
Yeah.